Hey everybody, how you doing? This is Brad Dyke reaching out to you. And today's little experiment is going to be a really cool one. I've heard people complain about this about TrueNAS and FreeNAS environments is how do you scale disk drives? And what I mean by that is, let's say you start out because you got your hands on 2500 gig drives, right? And you got a disk array and you put it all together and you kind of reach capacity, right? And so because you reach capacity, you got lucky and you were able to buy 10 new 1 terabyte or 2 terabyte drives. And you want to put these guys down there and take the older, smaller drives out, but transition TrueNAS in such a way so that you can make the transition fairly well. Now, unfortunately, the bad news is this is not an easy process. So I'm going to show you how to make it a little easier on you. So what I'm going to do first is I'm going to be booting up my power server over here, what's called my primary function server. I'll bring that DX720 up, and then I'll power up my second 720, which is right over there, which is the TrueNAS platform, and it's running on SSD drives. And I'm going to power that guy up, and then I'll access the TrueNAS web interface to show you how you can do this through the GUI opposed to the CLI process. It's not as painful as you think, but I'll walk you through that process. Stand by. Okay, now that I've got the arrays starting the process to boot up, and those drive systems are starting the process of cycling up, you're hearing them in the background. It will get pretty noisy for a little bit until the boot BIOS process clears the fans themselves in such a way so that you're going to be okay. Now, these hard drives are really special because these are the 10,000 RPM drives base that which you're working with. And also, you want to make sure you have one of these. This is a Phillips head series number 0.5, which is really good for the types of screws that you're going to have to deal with. And I'll show you that process as part of this 1, 2, 3 that I'm walking through. Now, as the operating systems are posting, and you can hear the noise in the background, eventually my noisy chassis will get quiet. But unfortunately for now, it's got to go through its posting issue. So by talking to that, the other thing that's important here is to know that I'm also doing two other things here. One, I'm going to deinitiate drive groups, what we call pools. And two, I have deassociated two other storage arrays from my storage head server. What that basically means is I'm getting ready to transition to SSD 1 terabyte drives. Can't afford the expensive drives, but I can at least transition to the SSD side versus spinning disk. My TrueNAS is going to have spinning disk drives because it's something I run periodically. I don't run these guys constantly. That's a mistake. Don't run your TrueNAS at home 24/7. Schedule its uptime, schedule its downtime. That's really genuinely good security practice. Your head server is a different case. That one you can afford to keep up and running, and it's the one that's going to handle all the day-to-day traffic. But there is no real reason to have a TrueNAS platform running on the back end if you're not doing point-to-point sync. That's your cell phones and laptops and things like that, not in your house, synchronizing through an internet connection to your TrueNAS platform, or you're not doing a replication sync or a file home replication. If you're not doing any of those things, then just simply keep it easy and bring the array up, back up your data on a scheduled job, finish and confirm your data is good, and then cycle down your TrueNAS platform for two primary reasons. One, InfoSec tells you if you don't need it on, it's not a security risk if it's turned off. They're spot on. That's correct. The second part is the liability and warranty life of your spinning drives and so on are finite. So take it offline. Make your hard drives last longer. And the adage about hard drives don't do good when they're posting over and over and over, not true. These are enterprise class drives, not desktop PC drives, okay? So 15,000 RPMs, 10,000 RPMs, even enterprise rated 7200 RPM drives such as the Seagate Constellations the Hitachis, and so on, and the Dell drives, they're rated. So use them, right? Abuse them. Do what you got to do with them. But the key value here is that make sure that you're taking the time to do what you've got to do. And the other key detail here is understanding that TrueNAS is like any other Linux environment. You have to follow the steps. So pay attention to that, especially with what I'm going to show you here in just a few minutes. Okay, so we've got the TrueNAS platform coming up online now. And also I have the other DX720 posting for its ability to do what it needs to do. And that is get us to a GUI interface so that we can walk through that process. So there's the second 720, and this is the TrueNAS platform. And I can't do anything with the TrueNAS platform until it's fully posted. So stand by for just a second and I'll let that post. Okay, so we are here now. And as you can see here, I am logging in into TrueNAS. I am using the root for this particular exercise, just so that I can avoid some issues. And so right now, the health is good. Capacity is there. It's showing plenty of memory. Got lots of resources. My SSD stacks. I don't really play much with the SSDs. Those are for the jail and for the plugin services and so on. But here is a test for 65 gigabyte architecture. Gigabyte architecture pool. And then here I have the 931 gigabyte architectural pool. These are pools of disks that I have out there. And if I go over here to storage and I go to the pools themselves, I have them in existence. Now the good news is down here, as we have our groups out here to play with, this is all going to go away. So the 931 down here on the bottom, the 465, the 419, all of those drives will be removed. And these will be reprocessed. In other words, I'm going to restage them in a correlation to make sure that the res are exactly the same. Now, in this particular case, I have quite a bit of capacity already, 7.12 terabytes of capacity, but it's no good to me. So what I've got to do is I'm going to dysfunctionalize those and decommission them. Now, the way you do that is under the pool value, you want to first go to your alerts up here and find out if you have any devices. I do. I have a dev.device DA12. This is a drive that is failing. So because of that, I need to go down to disks and see what A12 is. A12 is it's a 1 terabyte drive. So I'm going to write that information down. And this is very common. Your HBA controller interface will test and stress disks using smart mode and smart communication. If you don't have it enabled on the platform itself, then you are going to set yourself up for a point of failure, and you don't want to do that. What you want to do is you want to let these things run, let them find the drives bad, and then you can tag them to remove them out of your system. And I'll go over that in just a minute. But now that we've got that, and we know that our disks, most of the disks are good, I'm going to go down here and start decommissioning them. First, I'm going to get rid of this big group, and the way you do that is to over here on the gear bar, you'll come up and you will go to export and disconnect. Now, if you have an active style session, you will have to decommission the shares and all other things, okay? And down here, when you know you're able to delete this pool, is when it tells you to please type in the name of the pool. If it does not give you that list of the name and the ID, then that means you still have a share or a service that is bound to the pool. You need to remove all of that first. Once that's done and you confirm, the disk pool will be destroyed. And it is going to be gone in 3 seconds. 3, 1, and it is gone. So now I have reduced my pool of basically 4 down to 3, actually, it's correction, 5 down to 4, and I have another fairly large group of 400 gig drives here. I'm going to do the same thing. This is for test 465 GB. So again, I go over here to the gear. I go up to export, disconnect. If I've got absolutely no share associations in play and I want it to be completely destroyed and I want it to go away, again, it's going to say, okay, you're good to go. Please type in the name of the volume pool. And in this case, it is going to be test 465 GB, and it will bless it, and then I can destroy it. And it is now gone. So I have a set of disk drives in here that are both 1 terabyte and 400, and they're segmented off in the channel groups, which I'll talk to that later about. But principally, I have these disks. I'm going to expire these disks. I'm going to retire them. And I may give them over to my son to work with on his platform. But as you can see here, I'm just getting myself ready to decommission disks and bring in new disks and bring them into the equation. So I'm going to confirm this, and now all my 400s, or equivalency ofs, have been phased out. I think I do have a couple of 600 gig drives I did not allocate into pools, but I want to go over here to disks and just confirm. Yep, see them? Got a few 500s. They're odds and ends. And unfortunately, if your make and models are not the same and they're not exact, then you're going to have problems with this setup. So at this point stage, I'm now clean. Only 1 terabyte drives are in the discussion. And I need to find that one bad disk, which is identified as DA12. That's what this guy right here. And need to make sure that he is what he is. And to confirm that, yeah, I've written that all down. So I think we're good. And remember, it was the smart feature that tagged this as a bad disk drive, and I need to clean that up. We're going to talk to that in just a minute. So at this point stage, now I'm going to go ahead and cycle down the TrueNAS platform. You will not be able to do a GUI refresh with removing disks and putting disks in. It doesn't work that way that I've seen. Now you can CLI it under shell, which is an option down here, and then you can force a refresh on that. You can do that, but it's a little bit more advanced if you're not into that and you just want to be a core power user, not a core CLI admin. Then just basically power down the unit, as you see me doing here, and go ahead and allow it to cycle down. Okay, so at this point in stage, my DX720 is powered off. It's in a passive state, which is good. And then down here, below out of your view, is the 2246 NetApp DS array, disk array. And I'm going to adjust the view so that you can see this in time. But for now, we're just kind of getting you into the process a little bit here. Over here, I have a stack of my hard drives, which are right here. There are 10 of them. And I have roughly 7 additional drives in here as well. And I'm going to, at this time and point, I'm going to remove those disks. And I'm going to try to keep maximum capacity disks in there. Anything smaller than, let's say, 465 or 465 or lower, I'm going to remove. So that should give me some pretty good clearance. So to begin the process, I'm going to first try to see if we can identify that one drive. And I'm going to put this focus in here very quickly here for you so you can see this. And then this will allow you to kind of get an idea of the inner makings and processes of drive swaps. Now, I'm not going to do this entirely by camera. It's mundane work. It's take the screws out, put the screws in, put the drives in, right? So that's basically, I'll do a little bit of that show to you and let you see that. So stand by for a second. Okay, so these drives, these are the Dell drives. They're Constellation Class 2s, and they'll say X9G class. And in my case, I'm looking for an X9 G Class 3. These are G Class 9s. So it's not very difficult to find that drive because it has a designation ID on it. And so that's an important detail. So as I'm removing these disk drives, and yes, I'm pulling them out live, I found it. This is the failing drive. Its ID is correct. 9XG30W Victor November. This is the drive that's giving me the headache. So I'm going to pull him out of the equation. He's failing. And I'll give you an example here. Hold on a minute. Okay, so as you can see, these drives are live. Their LEDs are lit up. This array is the only thing powered up right now. The actual DX720 is offline. So I can take these drives out. And I've got 1 terabyte drives here. And I'm going to move them all make and model wise to the same side. Okay, so that's an important detail. Because remember I told you, as you're building these out in here, you want to make sure that you're doing it the right way, right? These are there are 3 separate channels here. One here, one here, one here in the middle. So as these discs are paired and set, you want to make sure that you're getting them properly matched, okay? Now that's a little bit of a challenge to a certain degree, but it's also very functional. So I'm going to put all these exact match models here together. All right. And this group of discs right here is the start of the Dell Series 1 terabyte drives. We'll put those in and let them trigger up, and they're spinning up now. Okay. This is a Seagate style drive. It is not a Dell drive, but it is a 1 terabyte drive, and it matches the same classification of the new 10 1 terabyte drives I have here. So these are going to be paired together. Now to do that correctly, for now I'm going to put the lead disk in. Since this is still the same class of drive, same level, it can sit on the same channel or more channels without any impact. Okay, so we'll pull all these constellations out and check them, and then what I'm looking for next is I am looking for the 400 gig drives. And voila, Hitachi 400 gig drives. These are the drives I've got to phase out. So I got to remove all of them. 3, 4. Plus I've got the 1 terabyte drive that's failing. So I'm going to go ahead and take him apart real fast. Now, believe it or not, I'm not a fan of 4 screws. And the reason why I'll show you. So this is a 2246 chassis caddy drive housing. And as you can see, it's very robust. It's got a lot of structure to it. And they do tell you to put 4 drives in it. Now, there is a reason why you should put 4 screws in a drive to hold it in place. I'm sorry, I meant to say screws, not drives. The reason why is because of what we call a vibrational state. You can actually yell at your disk array, and as you're watching your disk performance monitor, you can watch your monitor go nuts while you scream at your disk array. And that is because hard drives are sensitive to sound waves. So if you put 4 screws in, that transition from outside noise to inside noise is complete. Now if you put 2 screws in, one on each side, counterclockwise each other as such, like that, one up at the top, one at the bottom, The other side acts more like a shock absorber. So you're not so much prone to having sound waves have such an impact. And you wonder why I'm saying that? Well, can you hear it? Right over here. This storage array is noisy too. So they kind of affect each other. So I've learned that surprisingly, the decibels aren't so strong. It takes a lot more noise to affect them because the drives are not solidly mounted and creating a flush contact surface. It's a little bit of physics. So as I'm going to go through now, I'm going to pause the video while I get more of these disks swapped out and get these 10 1 terabyte drives swapped over and put in here, and then we'll do the power up, and you can see how I will bring that group back in while the TrueNAS stays in operations as it is. All right, I'll be right back. Now, while I'm doing this, as you can see, I've got getting the numbers down successfully. You've noticed that this array has, this 720 has a lot of open bays. And I only have 2 drives up here in the front. These are all empty, and all of these are empty as well. And you're probably saying, well, hey Brad, why are you using a disk array solution down here on the bottom, right, when you've got all this space in the chassis? Well, for 2 reasons. One, I'm a storage architect, I'm an operations architect, I'm a DevOps director of operations, and these are HBA driven. That means host bus adapted driven. And there's a RAID controller in the 720 for RAID testing. Plus, I can double my disk capacity to allow me to do this, but when I do that, it's going to be done in a different kind of way. Now, an HBA is strictly that. It's HBA only, and that's it. A RAID controller, on the other hand, can be both. You can build your RAID groups as RAID zeros. Each individual disk is basically built as a RAID 0, and that allows you to basically have individual RAID groups for individual disks, and they're kind of treated like an HBA. But when you go into TrueNAS, all TrueNAS sees is just like it would with an HBA controller, 24 disks, each individually typeclassed and ready to be deployed. Now, here's a trick. Can't tell this out too loud, but you actually get the benefit of RAID and you get the power of HBA. Let me explain. You see, when you have an operating system that's using, let's say, ZFS, right, TrueNAS kind of environments and so on, you have a little bit of a variable in the equation. It's software. That's the variable. Your manager, your management, and how it communicates is all in the software. But RAID controllers, on the other hand, work in the hardware. They're on the logic of the controller card below the operating system. So you can get the best of both worlds, actually. You can get the quality of RAID controllers, and you can get the quantity of the HBA controllers, turning your what I call just a bunch of disks into a pretty interesting combination of protocols. And yes, you've broken the mold. And that's not what they recommend you to do, and you're cheating, and you're getting away with basically storage murder by taking RAID controllers, setting all your disks as RAID 1 individual disk sessions, and then turning around and HBAing them through the software tool. And now you can go out and use your RAID controller software diagnostics to talk RAID language, which is at the hardware level, while you're doing performance matrices on your TrueNAS platform, and one may never ever see the other. Now, you're thinking to yourself, that doesn't make any sense initially. You're right, it doesn't. If you think of RAID 0 only. But what if you were to, let's say, take 24 disks, right? And you RAID 1, 0, 2 disks at a time for 12 sets of disks, right? Well, the trick with that as you have to understand, is you have basically 12 HBA discs that are RAID 0, but you're RAID 1 each pair of discs in RAID. And that's double set redundancy, but the I/O write cycles are 0. There is no risk. Because there's not a risk, you're able to get some of the powerful benefits of RAID added on top of the HBA mode. Because really, when it comes to software software HBA control, where you have a basic dumb controller that just says, "Hey, you've got drives, go do something with them," and hopefully you've got a good software package like a TrueNAS or something like that. You actually don't have that at all. You have the RAID controller configuration in play, and the RAID configuration tool is doing its job at the hardware level, completely eliminating that overhead, and yet all the OS level communication of the disks is strictly performance. So, did I just break the industry standards? Yes, I did. What is the value of doing this? Well, the truth of the matter is the value is a little bit limited, but the protocol communication is wonderful. Those of you who are old school and know RAID controllers and so on should know the RAID protocol communication level, or DSM. That's Disk Management Services. It's a powerful tool, and it does a lot of stuff without you. It's very intelligent, it's very functional, and zero maintenance. Literally, I mean, it will hot swap, flip, flop, and flip everything in such a way so that it's not even a blip on the radar. That's the cool thing. It's called dual layering protection. So if you had 24 disks and you set up 2 disks as hot swaps, that gives you 10 RAID 1 pairs of disks presented as 0. We call that RAID 10. If you had multiple 2246 disk arrays, let's say 6 of them, you could have 100 plus disks in basically, let's say 10 grips of 10 with 6 spare hot swap drives. And you present them as RAID 5, or you go RAID 6 if you want, but they're RAID 5 plus 0 or RAID 6 plus 0. Get it? When TrueNAS comes up, all it sees is 0 drives, 6 basic high capacity drives, and it runs with it. See how it works? So it's called ultra high redundancy. I've done it before. Really great for business continuity. It's tricky. If you don't know, if you've ever done it before, it's something that can give you some added value. It's really not a headache because we've got so many spare disks that, they were cheap. So why not? What the heck, right? Have spare disks, have hot swappables ready to go. It can't hurt you, right? Let's see, what do we got here? We have, I think these are 600s. Yeah, these are 600s. So now I've graduated to 600 level drives. And I'm going to go ahead and mount this guy up. Get him going. Alright, so let me get the rest of these disks and we can get to the next level and start showing you the initiation process of the disk controllers and how they bring these disks into an operational state. Alright? Be right back. Okay, so now what we have here is we have the disk arrays set. I have what is known as a dead drive. It has no capacity whatsoever at this point stage, and it is sitting here as a divider between these 6 500 gig drives, which will be 5 drives in a set with a hot swap 500. This is good for playing with things like you want to dump ground or something like that. Over here on this side, I have the 6 1 terabyte Dell drives, and I'll probably end up doing the same thing with this as these guys are set up. I've got a dead space here, and I've got 10 1 terabyte drives here in the middle. So now I have no functional capacity on the Dell. The Dell is offline, as you can see here. And then as we come back down here, you'll see me initiate the process of starting this drive sequencing up. All right. Now, I'm doing this from order to order. By doing this, I know that these drives will all stay in the same drive ID on the back-end controller. Now the back-end controller is on the back of this disk array, not in the disk, not in the HBA controller up on the server, but it's the back end, because this guy relates communication information up to the Dell 720. So I'm sequencing the drives in order so that they are going to be correct. And then this guy will be a blank, which I'll insert him. And that is an inactive drive, and identified that it is inactive. And now this part of the re-engaging of the drive process is done. The back-end controller of the array does not need to be powered off and powered back on. This is fine. This is not a problem. And then at this point in stage, we can then go ahead and initiate powering up the 720 up here. And as you can see, it's going to get loud, and it's going to start powering up. Now give me a second here while I reposition myself so we can keep doing this. Okay, so now at this point stage, you're starting to see the process of the HBAs coming online. Here are the HBAs, and there are all the drives. As you can see, there are the rest of the drives, and they are all coming up now. So now we're going to give it a minute here to go ahead and start the process of posting, and we'll go to the next step. Okay, so we're past the point. Now we're coming into the boot of the TrueNAS platform. I had basically 46 pathways, and you're probably going to ask the question, wait a minute, I only had 23 hard drives. Why did I show 46 pathways? Well, the reason why you had the almost times 2 pathways is because on the back of the actual RAID controller, if you look at the back of the RAID controller, you'll see this cable right here. And this is called a fail path, this cabling right here. It's hard to point it out to you while being at this angle, but this cable right here links your secondary controller to your primary controller, and that creates an alternate pathway. Now, if I wanted to go true full NetApp mode, I would run that other port over there on the far side up to a second controller, and I would have 2 sets of dual pathways. So this is where enterprise hardware is different than your store-bought home baseline hardware. Now let me explain. You know, a DS2246 disk array and all other forms of disk arrays have 2 sets of controllers and 2 paths per controller. So when you want some functional redundancy on a single controller, you can plug your interface cable into the controller in your server and then route the other channel side back to the primary side as an alternate pathway. So when your RAID controller boots up and it begins to come up to the point where it's going to begin the process of detecting the paths of the disks, your controller, specifically let's say TrueNAS OS software, will say I see dual paths. I only see a single hard drive, it has 2 paths. Now if you had 2 RAID controllers in there paired as one, and you had those pathways set up, it would say I have 2 pathways and 2 failovers. Right now I have a single pathway with 2 failovers. But it works. You know, I don't complain. It's great. It's a poor man's version of an expensive solution. I don't want to keep buying multiple sets of controllers to put in my servers just so that I can say I have 2 alternate sets of failover pathways. What I want is basically a solution that does what I want, right? So with that being the case, we are going to now begin the process of logging in to the server and get this server transition to its next stage. Hang on just a second, I'll flip the view. Okay, so now we are at the login. The TrueNAS came up in the clear, and I've got to get rid of this alert because I forgot to purge that. That drive is no longer present. And then go back to this. Now I've got a clean system, and down here I've got I'm using advanced display mode so I can see CLI command lines, anything that would happen or anything like that. So the very first thing I want to do is to confirm that my storage pools have not been affected. Should be 3, right? right? And there's my third component of it. So my two pools, my SSD cache and my SSD high performance disk. So everything beyond this point will be spinning disk. So, and I do show my active share state for that, for file systems. So now I will go to disks, and I need to see if I have disks. Okay, the good news is that the particular ID of that one DA12 that failed us is no longer the 9SP32 3 series. It's something totally different, and that's perfect. That's what I wanted to see. And I have, I'll have to check those out. Yeah, those are 500 gig drives, and I did trigger those first. I wanted them out of the way immediately, so that's why they came up first. This goes back to what I was telling you about the controller on the disk array tracking when disks come to life, right? Now beyond that, now you should start seeing, yep, there are 931.51, and basically they're showing many of them. All right, that is good. Okay, so we have our numbers. We have lots of them, and they are present, and they are not in pools. That's good. So now I can create one large pool of probably NFS or NTFS storage capacity, and then one small, what I would call temp capacity. So let's go ahead and do that now. I'm going to go up to pools. I'm going to add. And at this point stage, I am going to create. And I'm going to give this, I'm going to call it 931 GB drive. That's just telling you that it is basically a series of 931 gig drives. And we'll put a plural in there. I am going to encrypt it. It's going to get mad when I say to do that. I want to confirm it. That way nobody can steal my data off this machine if they stole it. And now it's time to put disks in. So I'm going to put all but one of the 931 gig drives into the pool. Okay. All right, so we'll do all but one. And it's going to ask me to place them, which I just did. I put them all into this lower group. So all of these 1 terabyte drives are now grouped multiple, which is 16 total, as you see right here. And then it's asking me to do RAID Z3. I'm going to say no. We'll do RAID Z2. That will put 2 drives out of commission, but act as functional failovers. And I've got everything I need. And if you don't create a name for the drive, you will not be able to create the drive. And then I'll hit create. I'll confirm. And now the drive is getting formulated. We have a call error on one of the drives. Okay. So that was disk 38, I believe. This one right here. So I'm going to pull him out. And we'll try this. I'll go back up here. And we'll put him in instead of its place. And reinsert it. Change the RAID grouping again. And create. Confirm. Okay, so the EN1 error is posting, which means there's a type class issue. We'll step it down to basic. See if that clears. No, it will not clear. Okay, so that means there's something specifically going on with the non-multipaths. these basic drives right here. So I'll pull them out, and I'll make sure that only multipaths are in this equation. And then I'll investigate why these drives did not come up correctly as they're supposed to. These are generating call errors. But that won't stop us from doing what we're going to do. We're going to go ahead and go with Z1 style footprint. That's 9.9 terabyte of capacity. And we're going to go ahead and initiate this. Remember, you can add disks on the fly. That's not an issue. And creating these is not difficult at all. So at that point, oops. Oh, my bad. I forgot. I started it with, let's say N. You can't have a number at the beginning of the naming standard. I keep forgetting that. It's a TrueNAS ZFS thing. It's not, you know, true hardware doesn't care. But we'll confirm it, and we'll kick it off again. And then that should finish it. Because I've encrypted this, I will be required to download the encryption key, and then it will be done. Now, we have now set up here a new set of disks. I have got 9.55 terabytes of capacity right there, and it's operational. Now I can go back in again, add another pool, and I'm going to create. This time I'm going to bring the 500s over, all but one. So I'll put up here N 500 GB drives. Naming standard is valuable, so I would do it. And I will enable encryption. It's software encryption, so it's okay. I'll acknowledge that. And we have everybody but one, which I'll set this last drive up as a hot swap. And I will go down here and I will add them into the data devs. And now I've got the drives that I want, and I want to keep this baseline at Z1, RAID 1, which means I'm only going to lose one disk out of the equation. So I've got just short of 2 terabytes of capacity. And I'm going to create this, and it will come up here in just a second. Again, because I'm doing encryption, I want to go ahead and download that key, which will be sent to your download directory. Make sure you send those off to a safe haven share so that you have them out there in case you need them. And so what that leaves me with now is basically just a few hard drives. I'm going to add, I'm going to pick one disk, this one, bring them in, and I want to identify this particular style. Now I can make this guy a single stripe disk, and I can force him into existence, which is not optimal, not really. But what else can you do here? Well, you can actually go into and create hot swaps, okay? And by creating hot swap, 500 GB, and I can then state and configure this drive to be what I want it to be. And in this case, I want to enable the hot swap capacity. And I'm going to bring him out real quick. I apologize for that. Bring it out. Okay, set to hot swipe state. Yes. And bring it back in. And import it down into the spare. It's down here. You see it says right there, spare dev. And then at that point stage, it's going to be ready. And I'm also going to go up here. That supposedly we're going to be able to do this now, so I'm going to test it just for giggles. I'm going to bring in a 900 as well. And at that point, I am going to force it. And at this, now I'll have myself, oops, sorry, my bad. Let me take that out real quick. No, that should have worked. Take that back out. Let me reset it. Change the ID name so it's reset. Set to hot swap. Go down and add. Select mode. Again, add. These are not, oops. Yes, it is. I did it again, didn't I? Jeez. You thought I would learn, right? Let me try that again, shall we? I was trying to bring over two of them. Okay, and at this point in stage, I'm not going to initiate this yet, but I basically set these two 931 gig capacities as hot swaps. And I can do the same thing on the 400 series side, which I only have one to work with on that one. But I can basically set these in as an active pool to do what I want it to do and give me the ability to cover these pools. Now, my pools have already placed their redundancy drives in there. This is just an added level of protection. You already have a spare drive in your parity set, or if you did Z-RAID 2 or 3, you could have even more disks in standby mode to accomplish that. But I wanted to show you how to bring up and get this to communicate the right format. There still seems to be some tweaking that they need to get with the spare mode. I'm going to figure that out, and then I'll probably do a video on that later. But as you can see here are the 500s right here. They're the 1 terabytes right there. They're operational and ready. And at this point in stage, the next task is to go into sharing and enable, and then start tagging to user accounts and all that. I'm not going to go into that. This wasn't about that. This was how do you transition hard drives in a real-time state with the environments in a clean 1, 2, 3 process to get you to where you need to be. So this is one of my longer videos, but the value behind the videos is that in this case, you really can do a lot with TrueNAS. And you can also mess around with your RAID controllers, and that's what I hope I inspire in you is, wow, we can break some rules here. And there's one other critical thing I want to touch base with. It'll just take a couple of minutes. And that is, what do you do with your leftover hard drives? Now, this drive is no good. It has to be tested. It's probably bad. That was the one that was giving me grief when I first built out the TrueNAS array on my first video and the second video. But these 420s and the couple of 600s here, they're valuable. Why? Well, for a couple of reasons. One, that's a DX720 array. Look at that thing. It's got plenty of capacity, right? 24 bays right there. And I'm only using one. So that's one thing. We can do that. But there is a problem with that. This is on a different RAID controller. And when you're building your pools, you've got to remember, especially when they're similar disks like you've got in your system now, you have to remember a very crucial detail. And that is, you do not build pools across different controllers. In other words, you have an HBA controller on the back of your 720 connecting to a disk array. And you have a RAID controller inside your server that is connecting to the internal disks. I've seen this happen. And unfortunately, it's happened on hot swaps, where people just grab a drive that they find out there, but they didn't research where the disk sat. And the next thing they know, they're saturating both their HBA controller and their RAID controller heavily with way out of control I/O. And what's going on with those IOPS is you're trying to run performance level data writes and reads across totally two separate storage platforms. Not a good idea. This is why NetApp will do 10 or 13 or 15 2246s in tandem using those cables I saw you saw in the back to one HBA or two HBAs, and that's it. They don't add another set of controllers in the equation. They just put it all through one pair or a single HBA controller. So you need to be a little careful when you mix controllers, HBAs and RAID controllers. They can kind of come back and bite you. The biggest crucial thing to do is make sure that you block them off, you document them, you mark them, you clearly, say in the volume names where these discs belong, and so on, so that you don't make that mistake, because it can be a kiss of death. So with that being said, I'm going to stop talking now, and I'm going to stop this video. I hope this helps some. This is more nitty-gritty. I know some of you guys don't like to go down that technical level, but please remember that when I do these videos, there is an expectation of certain things I have to expect that you know. It's great that you want to learn more, but if you don't know, take a little bit of time and research it so my verbiage and the things I say will make better sense to you. With that being said, I hope you guys have a blessed week, and I'm going to let you go. And I hope this is a good video. If you like it, please like it. If not, hey, give me some comments on how I can improve on it. It is a cell phone, after all, that I do all this recording with, so please forgive me on that side of the front. But you guys have a blessed week and weekend, and have a great Christmas.